Okay, so a new circuit we're going to need to look at is the 4017 circuit. It's a decade counter. It counts to 10 every time you put an input signal in. So it's a process, okay? Now it does come up in the exam, okay, looking like that quite often. It's really, really simplified, okay? It tells you how many outputs you've got. It might even tell you what your input is going to be, okay? All right? It often tells you how they want you to complete the diagram. So it's a little bit of a checklist for you to do. So for example, connect the microcontroller output to the clock input. So here we go. There, okay, is my microcontroller. They've really simplified this stuff. It's an output there, so guess what? It goes to the input over here, which is the little circle with an arrow. The arrow is pointing in. That means it's an input, okay? So I'm happy with that. That's connected. So I can give that one a nice big tick. Connected the 4 LEDs so they flash as intended. Okay, so I've got 4 LEDs. Okay. Okay, and we're going to literally keep it nice and simple. Again, there might be different outputs, but just bear with it. Okay. Hasn't asked you to do it, but we are going to put a protecting resistor in just in case. Okay. All right, and as with every circuit, we know it's got to come back down to the ground volt rail just there. Okay, don't forget those little dots. You never know what the examiner is trying to catch you up on. So good, I've done that. Connecting the enable pin. This really is easy. Enable, N, negative. It's going to go down to the ground. Again, connect it up. All right. Now this is the hard part. It says connecting the reset pin so the LEDs are constantly flashing. So when I get one signal coming in, it's going to do that. It's going to make the first one light. When the next one comes in, the next one will come on. The last one will go off. And it'll keep doing that. So go on, then on, then on, then on. We want it to reset. Otherwise, it's going to try and set a signal out there, and then reset. We want it to reset after those first 4. So what we're going to do is we're going to put in a reset button. Okay? We want it to be automatic. So I'm going to take this back round to here and connect it into R for reset. Okay? So that little signal, instead of making a 5th LED light, it'll send a signal round and we'll reset there. But it needs a couple more things. It's going to need a pull down resistor and a switch just there, and there you go, it connects. Okay? So I've got the ability to, say I want to stop using it, I can press that button and it'll send a signal to reset the whole thing, or it's going to do it automatically. But it does have to have that pull down resistor. The value for that one won't change. It will always be 10K. And that's it. That is how you set up the 4017 decade counter. Read the question. It'll tell you what it wants you to do. Okay, draw it as neat as you can do. Use a ruler, make it look neat and tidy. Don't forget little pins like that. All the little connections, there you go. I'm going back through and checking it and realise I've actually missed a couple of them, and I'm happy. It might not always be this that is your input. It might not be a microcontroller. It could be anything else that sends a signal. Could be the 555A stable that sends a regular repeating signal which makes these ripple through and keep lighting up. Could be the monostable.